Hi, this is Elizabeth Morales-Carbajal, and today I am doing my equilibrium lab. And the first step is to, cut off the tip of the pipette, but this is in here and here. So I'm gonna label this potassium chromate, and then I'm gonna just suck up all the liquid and just do that, and then I'll go to the next step of the experiment. Alright, I have my potassium chromate labeled and put right here on A2 how is shown on the lab instructions, and now I'm going to add 8 drops into B2. 1, 2, 3, 4, 5, 6, 7, 8. Okay, after we added the 8 drops. Okay, the next step is to record the color of the chromate, and it's like a bright yellow color. So I'm gonna record that, and then we will go on to the next step. Here we can see how it's a pretty vibrant color, but it is a dark yellow orange color. And yep, we can go on to the next step. The next step is to add 4 drops of hydrochloric acid into the potassium chromate to create dichromate. So we are going to do that now. Okay, here we see that it turned into like a bright orange color. So yeah. Okay, now because we know it changed colors, we know chromate changed completely into dichromate. So now I'm gonna record this on my table that the color changed from a yellow to an orange color. Okay, our next step is to add sodium hydroxide into our dichromate, and we have to add as many drops until it changes back to the original yellow color. So we're doing a reverse reaction. So yeah, now we're gonna count how many is needed to change it back. 1, 2, 3, 4, 5. Okay, I think that was 10, and I think it looks the same color as before. Okay, now for the next steps, I have my cold water in here, and then my hot water in here. And then now we are gonna place 8 drops of the potassium chromate into a new empty well. So I'm just gonna do the next one right under it. 2, 3, 4, 5, 6, 7, 8. Okay, and then add 4 drops of the hydrochloric acid. Okay. Next step says to use an empty pipette to drop all the potassium chlorate and the hydrochloric acid from the well in the pipette and then turn it over. Okay, so we are gonna do that, and I will be back when I'm done. Okay, here is all of my solution. Okay, now you can look at the color. It's like a pretty dark orange color, and I don't know. Okay, and then there's also a question asking if the products or the reactants is favored, and I say the products is favored because after we added the hydrochloric acid, there was an instant color change to orange, which proves that I lost my thumb. Okay, so that there is more dichromate, so which is the product, and it is favored in this solution. Okay, my next step is to add our solution into the cold water for 2 to 3 minutes, so I will be doing that. Okay, it has been 3 minutes, and honestly, the color looks a lot darker, not too much, but a good amount darker. And then I think this shifted more towards the products, because obviously it is a lot darker, so it looks like there is more dichromate in here. So, yep, let me go log that in, and then we will start with the hot water. Okay, now I'm gonna do the exact same thing, but with hot water. So, I'm gonna let this submerge for like 2 to 3 minutes, and then I'll be back. Okay, so now it's been 3 minutes. It does look a lot less darker than before. It's more like a brighter orange. So I believe that it is leaning towards more of the reactants now. So it's shifted left. So probably some chromates formed in this. So yeah, I will write that down in my chart, and then we will be going on to the next step. Okay, now we can go over these questions. So the first question asks, we're using our results to determine if the forward reaction in our solution is endo or exothermic, and we need to explain our answer using this table. So looking at the table, what we know is when we added temperature, it shifted left, so here is when we added temperature, so the hot water, and we see it shifted left. And then when it is cold, so we decrease the temperature, it shifted right. So when it increased temperature, shifts left, so it is exothermic. And then the same thing, when we decrease the temperature, it shifted right, and it is also exothermic. So for my explanation, I really just explained our results and looking at the table how it matches my results. And then here is for question 2. This is my balance equation. Well, not my balance equation, my equation for equilibrium constant that we used in this exercise. And then looking down, we can see, so what really changed, I feel like what got me at first for this question was that it was increased from, so we looked here, it says H2 equals this. But if we read up here, it says H2 was increased from 1.010 to the negative 2 to 2.5 times 10 to the negative 1. So, which that really affected my result. So that, and then at first I was like, wait, this seems wrong, and then I changed it, and then bam, it got the right results. Next, what we did, then I just did the same thing down here. I just had to change the h squared. And then for down here, we used the initial h squared for this one. So I had to use 1.0 times 10 to the negative 2. And then I also added, what did I change? I changed our numerator from 1.0 times 10 to the negative 4 to 5.6 times 10 to the negative 3. And then I got my answers, and see that Q here equals 1.6 times 10 to the negative 7, which is smaller than K, and our K is given right here. 6.0 times 10 to the negative 2. And then for the rest, our value of Q is greater than K, so it shifts to the left. Alright, now that I'm done with the exercise 1, we're going to go into exercise 2 of the equilibrium of ferrocyanide and ferric ferrocyanide. I hope I'm saying that right. But we will start with that. Okay, I'm going to go ahead and clean this up and dispose of these chemicals, and I will be back. Alright, now I am done cleaning up my wall plate. And then now, so we have our goggles and gloves on. We are going to do the same thing with the potassium ferrocyanide and the iron nitrate. We are going to put them into these little pipettes. I am going to mark the names down, and I will put them in here upright. So I will get done with that and I'll be back. So look, this is pretty satisfying. See, because a good amount of it goes in. But whatever I like. Okay. Okay, put that there. Close this up. The name. I got like almost all of it. And put this right here. Okay, and now we go on to the next step. You guys can see I have my solutions here, just how the picture says. So wait, let me switch these around. First, that is exactly like the picture. And now we will get started in the next step. And now in this step, I'm gonna add 8 drops of our potassium ferrocyanide into an empty well. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. Record the color. So we're gonna look at the color. So the color of the potassium ferrocyanide is kind of like yellow green, a very light yellow green. It's a very nice and pretty color, so we are gonna record that in our chart and then we will go on to the next. Okay, for our next step, we are gonna add 1 drop of the iron nitrate into our potassium ferrocyanide. So just 1 drop, and then we're gonna see the color and of the mixture and record the reaction into our chart. Okay. Oh my gosh, that changed so fast. Is that like a dark blue? That is so nice. That changed so fast. So I want to see if I give it a little. It's kind of like a jelly. See, it's like a jelly. So that is really cool. Okay, so now we're gonna do what we did last time, and we're gonna add some sodium hydroxide into our mixture to see if it changes color back. We're gonna see when it changes color back and how many drops it takes for the color to change. So let's do that. So dark. 1, 2, 3, 4, 5, 6, 8, 9. It's been 10 drops, but I feel like those are like solid parts in there. So, yep. I added a few more drops and they don't go away. So, yep, they look like little solid bits in there, so that's really cool. So looking at my data table, what I saw for the color of the potassium ferrocyanide is it was a really bright yellow-green color, and then obviously when we added the iron solution, we got blue-green color, and then that when we used about 10 drops of the nitrates, what is it called, sodium hydroxide solution. I don't know why I said nitrite. And then we saw that this observation that like after we added the solution, when we shifted back to the light yellow color, is that there were some brown participants in the solution, and they're still there. So that is really cool. Alright, and for the question we have for this exercise is from our observations and data collected in table 3. Here's our data. Describe the direction of the equilibrium position upon addition of NaOH. So what I got was when we added it and the equilibrium shifted left, because when we added the NaOH, the iron ions of the solution were basically like removed. So then like to create more, so like basically the reaction created more reactants, and this is like what caused our reaction to shift left. Okay, I kind of changed my answer, so I wrote that the equilibrium shifted left because NaOH removed iron ions from the solution, so the reaction created more reactants, and then I added that our reactants are the iron nitrates. So yeah, that is it. Now we will see what we have next. I hate when it does this thing. Here we go. Now is the evaluation. Did you complete all of the required exercises and assessments in this lesson? Yes. If are you confident that you achieved the learning objective listed below? Define chemical equilibrium. Yes. Yes. Yep. 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 Now we can start our evaluation. Alright, I am done with basically everything. I'm just now looking at the final report and making sure I answered every single question. So alright, I answered every single question. I'm going to submit my data and upload this video. This was such a fun experiment, and yeah, bye.